Bismillahirrahmanirrahim. This is the revision actually for phasor diagrams. Actually, most of the students asked when I was in live session with the students. So, the better understanding, you just focus this. This is the phasor diagram for three-phase currents, and this one is delta connection. So, how phasors can be drawn? This one is red phase, this one is yellow phase, this one is blue phase, and each and every, because this is three phase, so red phase is 120-degree apart from blue phase, and blue phase is 120 apart from yellow phase, or the blue phase is 240 apart from the red phase. See, from red to blue, 240-degree. So these are the phasors are. So this one is reference phasor, that is red phase. This is phasor current diagram, right? Because we are going to draw for the delta connections. So red phase, yellow phase, blue phase, they are 120-degree apart from each other. So if we apply Kirchhoff current law at this node, see this node, this is A, this is line A, this is this current. This current is the sum of IAN minus IBN. Why? Because see these are phase current, these are line current. This is line current, these are phase currents. So this current is towards the node, this current is away from the node. So minus sign equals to line current is the sum of two phase currents. See, line current is the sum of two phase currents, and one phase current with minus of the other phase current. So you have to draw the negative phasor of the other current, that is C, IAN minus IBN. So originally IBN was this phase. When you draw the negative vector, it goes like in negative direction, and it bisects 120 to 60-degree, right? And when you add up these two phasors, that is I minus IBN and IAN, two phasors, when you add these two phasors, again the bisector is of 60 of 30. First bisector for 120-degree, the second bisector for 60-degree. So this one is see 30-degree. So IAN minus of IBN is equal, this is Kirchhoff current law at this node, at node A. So see, in delta connection, this one is voltage is line to line voltage, this one is phase voltage. In delta there is no neutral, so line voltage equals phase voltage. In delta the line voltage equals to phase voltage, and the line current is under root 3 times phase current, that is line current is bigger amount. See in the phasors, this is line current, it is bigger amount, it is sum of two phasor currents. See, this line current is the sum of two phasor currents. This phase current and this phase current makes this line current bigger. So I think it is clear. Now the phasor diagram for star connection. In star connection, we know that voltages are not equal, but the currents are equal. That is, line voltage equals to root 3 times phase voltage. So the similar phasor diagram as it was drawn for the phasor current. This one is phase A, that is red phase. This one is phase B, that is yellow phase. This one is phase C, that is blue phase. First phase is the first phase, that is red phase A, is 120 apart from phase B. Phase B is 120 apart from phase C, and phase C is 240 apart from. If you see, phase C is 240 apart from phase A. So in this case, we have line voltage which is, see, in this star connection, the line voltage is the sum of two phase voltages. See, the line voltage, if you apply mesh analysis, over here, mesh analysis, then see the VBN minus of VBN, VAN minus VBN, this voltage means mesh analysis, VAN minus VBN is equals to VAB, This line is A, this line is B, is equals to VAB, right? So if when you come to the phasors, you draw that is, see, minus VBN, the negative phasor of this. So the negative phasor of this bisects 120 to 60 degrees. See, it goes in between from So it bisects the negative phasor bisects 120 to 60 degree, and the resultant phasor, that is VAB, the resultant phasor VAB bisects 60 degree to 30 degree. Similar is the case for the current. So VAB is the bisector for 60 to 30 degree, and this voltage is bigger than phase voltage. For example, the line voltage equals under root 3 times phase voltage. While the currents being same, while the currents being same. See, in line A current, this is line current, same current goes into the phase. So line current and phase current being same in star connection. See, the current coming from the line, it goes to the phase. The current coming from the line is go to the phase. The current coming from the line is go to the phase. So line current and phase currents are same. I hope you understand.